Hello there, this is the Tepid Coder. In this video, I want to do a C++ version of my linked list implementation. I'm going to try to kind of speedrun through this a little bit. So, let's see here. What I want to do, iterator. I want to include oStream. Include new, because I want to do standard no throw. Functional. I'll show that for an initial iteration thing with a callback function. Okay, so I'm going to do class node. Okay. It's going to be a template class. So template type name t, let's say. I'm just going to make everything public in this class. So really it should just be a structure. So everything's public by default. Okay, so I'm going to have t data, let's call it. I'm going to have node pointer to LP next. Node pointer LP prev. It's going to be null pointer by default. Pointer. Just use a default constructor, whatever type it is. I'm kind of assuming this node's going to be full of a structure, but this could be any type. Could be a class object, could be some primitive type like an int. Doesn't really matter. By not putting anything here, it's just going to use the default constructor. I could be more explicit and do this or that or whatever, but whatever. Actually, I don't know if I could do this. I think it would have to be this. If I do this, it's like the most vexing parser or whatever, where it's defining a function that returns type t and takes no arguments. Whatever. Template, type name t again. This time it's going to be a class called list. Okay, so I have some private members. I'm going to have node of type t, pointer, in front I'm going to call it. So I'm going to throw a pointer to the front of the list. By default it's going to be a null pointer. And then node type t m back equals null pointer. So I'm pointing to the back of the list as well. That way I can do insertions to the front of the list or the back of the list without having to do any iteration through any of the nodes in the list to find out where to do the insertions. The other thing I want to have is the count. It's usually good to have that. So mst count equals 0 by default. Okay, now we have our public methods. So what I want to have here is going to be, let me think here for a second. I'm going to have some iterator classes. So if you notice with standard list, there's like standard list t iterator, there's standard list t const iterator. I need something like that, and the reason for that is the nodes I have are not going to be contiguous in memory. I mean, they might be. It depends what the address of memory the structure gets when I allocate a new node. So there's no guarantee of contiguousness. In fact, it's very unlikely that it will be contiguous. So because of that, what I need to do when I iterate is store a reference to the actual underlying node, which has a pointer to the next and a pointer to the previous. And when I iterate, I'm just going to make it point to the next node in the list. And then I need to have access to methods to get to the data inside of this node. But the user should never actually see this node when I'm doing this in a C++ way. They get an iterator object, which lets them go from node to node, and they can access the data using some access to method within the iterator object. Which is kind of silly. I don't like it, because you have the list here, which already has like the nodes in it. It's nice and see how you have the data right here, and you have like the pointers to go from one node to the next all in one spot. There's no need to construct and destruct and all that, but the way you can make the type generic, so you have a structure that has a compile time data type for the actual data you care about, is really nice and convenient. So I am going to show this. I'm going to make it as C++y as I can. But before I get into that, I want to make it so I have more basic accessor methods. I'm just going to do it for each, and I'll get to that later in the video. So first thing I want is list. That's our constructor. I want our destructor. Okay. I want a push front, which is going to return bool, true or false. It'll take a const t reference. Okay. Do the same thing for push back, I think. I want something for erase. I'll take that a void. Erase. This is going to have to actually take like a standard list t iterator. Right. So I'll get to that in a minute. What else do I want? I want pop front. I want pop back. Void. Void. Yeah, void here too. I'm gonna want to accessor that gives me the count. That's const method, doesn't change anything. I mean, all these are no except too, really. Let me think for a second. So I have push front, push back. I have pop front, pop back. I have a count. I need a clear method. Okay, void, void. Okay, that's a pretty good start for now. This is gonna be a little bit tedious, but let's paste that over here. Okay, so list type T, template type name T. Oops. Cool. So now constructor doesn't do anything special. Yeah. Okay. Cool. Okay, let me think about this for a second. So pop front, what I'm gonna need to do for that is I'm gonna basically need to say erase m front. Pop back's gonna be erase m back, and then my erase is gonna be something like, I kind of want some kind of method that I can use internally to get the underlying node for that. That's a big to-do right there. I can make these easy for now. Since I have the actual node itself, I can say something like m front, delete that, right? But before I do that, I'm going to say something like if m front lp next exists, then I need to say m front lp next equals m front, or equals, sorry, not next, prev equals null pointer. Yeah, so there's one after us, it has to point to nothing when it goes backwards. Okay, then we delete it, then we say m front equals next. I need to store that next, so it's going to be node type T pointer next equals m front lp next. Okay, and if there's nothing after this, that's just going to be a 0, right? So that's fine. And over here I can say something like node T prev equals m back lp previous. Okay, and then we have if there is a previous, back lp prev, then m back lp prev lp next equals 0. There's null pointer. I'll do that. Okay, and I can say delete m back, and I can say m back equals prev, because I stored the previous position in memory. I can just delete that. Okay, that's looking pretty good. When I clear, I want to do things like mst count equals 0. I want to do things like actually iterate through the list, so something like, what is it, node type T next, free me. Okay, that's going to actually equal m front, let's say. I'm going to say while next points to something valid. Next equals next, lp next, free me equals next. Before I iterate it, and I'm going to say delete free me. Yeah, okay. We're getting pretty close to being able to use this thing. I'll do list, let's do int first, lst. I'll say lst dot push back 1. And I'll do lst dot push front, let's do 0 before that. Okay, and we'll do something like this dot for each. I haven't made this yet, but I will. Okay, not capturing anything, but I do want to take a t reference. It's going to be const int reference I. I want to make it return a bool so I can end the loop early if I feel like it. Return true, keep looping forever. I'm going to do something like standard cout, standard line, value. Okay. I like how that looks. Let's do a for each. Did I do that in here yet? I really don't think I did. So let's make that. So void, actually I want to do bool. For each. I'm going to do standard function, returns a bool. It's going to take const t reference. Yeah. Callback. Okay. That looks pretty good to me. Okay. So let's do that at the bottom here before main. Template, type name t, comes from list, specialized for t. Okay, and we're going to say something like node type t pointer in for node equals, it's going to be m front, so we're going to say while. I could just say something in the for loop, I'll do that. So while in points something valid, in equals in lp next. And I could make a reverse for each and stuff too, but I'm not going to for now. So if in callback, it's going to be in t data. I think I called it. So if this returns false, that means the user wants us to stop early. So return false. Something went wrong probably. Return true otherwise. They didn't return false to us. Okay. Now I actually need to push stuff to the front and the back of the list. Let's do push front first. It's easier. So m front if m front. Think about that for a second. I need a new node. So node type t pointer in equals new t. I don't know if I like that or not. Like, I could just do this, and then I could say n equals t. I don't know. Like, I feel like saying n equals t right here probably works with more types. It's probably safer, but this way over here is like quicker to execute because it can use the C++11 style initializer list where it doesn't like double initialize class members. So I'm gonna go with this method here. Okay. Now you just say something like n lp next equals m front. That even exists right now, and then n lp prev equals null pointer. This is going to be the new front of the list. Okay. And if m front existed before, then m front prev, so lp prev, equals the new node. Yeah. So this will, new node we made will point to the previous beginning of the list, and the previous beginning of the list will point backwards to the new node. And then I'm going to say m front equals n, because it is now the new start of the list. That looks good to me. Now, what I need to do over here is standard no throw. Otherwise, I'd have to wrap this in a try and catch block, and I'd have to catch, you know, standard bad alloc, right? I don't want to do that. So if I do standard no throw, like this, like you're casting, it makes this return 0 on failure. So if not in, you just say return false, otherwise you're going to return true. I like that. Okay, so now we're doing the same thing with the back of the list. So node type t in for new node equals new standard no throw t t. Okay, initialize the t. So if not in, return false, we failed to allocate, otherwise return true because we allocated properly. And then what I need to do is I need to say if m back, there's already a back of the list, so at least one node exists, then m back lp next equals the new node. Okay. And then n equals, or sorry, n lp prev, the previous node of the new node that we just allocated is going to be the previous back of the list, so m back. And the new node's next is just going to be null pointer because we're the new into the list. We push to the back of the list. Anything else I have to care about there? I feel like that's pretty good. Anything else I need to think about right now? Did I return the count yet? Did I make the count function? Where's my count function? Right here. I didn't actually return it yet. So return mst count. Okay. So before I do this, I'll test that out too. Standard cout. What is it? List count. Okay. There are that many elements in the list. So push back. Let's actually change the count. So mst count plus mst count minus minus. Okay, over here. mst count minus minus. Pop back. mst count minus minus. Okay. Count becomes 0 there. I'm missing one. Where is it? Push front. So mst count plus plus. Right over here. Okay. That's looking pretty good. I'm gonna see if this works. So I'm gonna have g++ test.cp out as test. We're going to do standard equals c++ 20. Okay. So on line 43. Right, list type T. Okay, and inside the destructor I need to call clear. So actually free the list. Where is it? Okay, here we go. Line 52 infront was not declared. I disagree with that. But it's because list T. Okay, there we go. I have to do that a lot of times now. Isn't template programming in C++ just such a joy? '84. Okay. Shadows that what? Oh, because right here. Oops. That was silly. 98. Note instead of node. Okay. Node. Okay. We have 64 now. Can I convert int pointer to? Okay. 64. Yeah, this is going to be a node type T. Right, okay. Now I just need to say the n t data equals t. There we go. That was silly. And then I need to do the same thing up here too, looks like. So it's going to be node type t, and I'm just going to say n t data is t, right? Yeah. That's looking decent to me. Just try it out. Tell what's in the list. Didn't show him though. Okay. Okay. So list for each. Let's actually look through that for each. One more. Okay. So we're starting at the front. Oh, when I actually add something to the list, and I don't have any members of the list yet, I need to deal with that. So front, what we're going to have to say here, where am I? Come on. Let's push front. Push front. Here it is. Okay. So, well, hold on. Front equals in. So that should work. Okay, and if not m back equals m front. There we go. And over here I can say if not m front, front equals m back. Right? I'll see if that helps. Nope. Okay, so what else am I doing wrong? Push back. I create a new node. I assign the data of the node. I point its previous to be the back of the list. I point its next to be nothing, which it should be. And the back next points to us if it exists. And then I say, where is it? So not front, front is back. Well, the back also needs to become this, always. Like, so m back equals n for node, right? That needs to happen before I assign it, though. Yeah. Because right here, I've already redirected it. And here I've pointed to it, so I can safely do that. Okay. And front equals n right here. Yeah, and I've already redirected that. Okay. It was the issue, okay. Did I do the push back first? I thought I did the push front first. No, I did. That's right, because I pushed the 0 in front of it. And it did print 0 then 1. Okay, so that is working. Okay, so now we get into the hard part here. So this is the part that I super not looking forward to, but let's get through it. So before I mention I need to have like iterators. So what I'm going to do is I'm actually going to define some classes in here. Some nested classes. This is going to be a template class, so template, type name, let's do K. It needs to be in a template class, but if I put T in here again, it would shadow this declaration right here for T. So I have to call it something else. There might be a better way to do this. Maybe someone can let me know in the comments later, but if they know and they're watching just for fun. Anyway, I'm going to do const iterator first. And what I'm going to say is I have something like private. Inside private, I'm going to have node type K. It's going to be a pointer. Call it mnode. Okay, I'm going to have public. I'm going to expose things like const iterator. And its default constructor is going to be deleted. Const iterator. If I give it a node, it's not deleted. So it's going to be not standard node, but just node type K. Gotta remember it's K now. It's a const iterator, so it's going to be const K, reference. Okay. We'll call it in for node. I'm going to say something like, where is it? mnode. Initialize that with the node for this passed. Okay. I'll have a const iterator destructor. Don't really need to do anything in that. So I hold in here is like a pointer. That's not ever going to happen because I have a default constructor other, but it's going to be initialized like this every time. So that's kind of pointless. So now I get to do some fun stuff. Fun, I say kind of sarcastically. Okay, operator not equals. I'm making some functions here which compare. So compare this iterator object and another iterator object to see if it is equal for whatever that can possibly mean. So I'm going to say bool. So const iterator of type K reference it. Okay. Now I'm going to say if, not even if, just return mnode t data equals, and it's going to be the reference, the place in memory where this t data variable exists. If that equals asterisk it. So I'm going to dereference it. So I'm going to have an operator overload asterisk, which returns a t and like that. If I do and t and, that gives me a t pointer like this. And right here, same thing here. I have t is my type right here. I'm doing and t, which gives me a t pointer. So I'm testing to see if those two things have the same place in memory. And I have to do something else too here. So bool operator not equals. And this time I want to do it for not const iterator, but just iterator. Iterator type K by reference it. And this can still be passed by const. Okay. And this is a const method. It's also no except This is also const no accept. Yeah. They should also be const no accept, really, but I don't really care to define that. Okay, so return, same thing here. I can basically just steal this line. Okay. Now let's make that operator we had earlier. So it's going to be, think about this for a second. I want the underlying type, which is actually k, not t. So k reference, but it's const k because we're in const iterator. It's going to be operator asterisk. Okay. Void const no accept. Okay. What I'm going to do is I'm going to return mnode p data. Yeah. So when I get to this, it's just going to be type t, but it's going to return a const reference to it by default, so it becomes tand. Okay. Now we do something else special here. So I'm going to do const k pointer operator arrow void. This is going to be const no accept, and this is going to return a reference to that mnode t data. So and t becomes t pointer. So the reason I'm doing this is so that if I have a structure is type k, so we have something like, I don't know, not standard list, but list of some struct, right? lst. Then when I make a iterator, I do something like list begin, which gives me a list some struct const iterator rather. That'd be c begin. Right, then what I could do is I can actually say something like, let me reorder this real quick. Okay, I did that backwards. I should do the other one. Yeah, it's going to be this. Let's call it it, say it equals that. Okay. Then what I can normally do, if I just used this operator at asterisk, I could do that and get the underlying type, which is some struct, right? And then I could do dot member, right? But if I have this, and I return a pointer, then instead of getting the underlying type t right here, right? Asterisk it gives me t like that. Instead, if I do it this, that's going to return a pointer. So now right here I have a pointer. That gives me a t pointer. So what I can do from that t pointer is just access the member directly. That's kind of the magic behind standard list iterator. So standard list t iterator, like that. That's what it's kind of doing for these operator overloads. So I'm glad I can finally show that off in a video. It's a pretty neat thing. Annoying to program, I think. I don't actually enjoy writing this, but at least I'm able to show it off, and people know how when they need to in the future. So we have a couple other things we need to define here before we can really make use of this. So I'm going to do something like, let me think. I kind of want to keep this easy. I'm just going to make return void, operator plus plus. Okay. This is your pre-incrementer right here. So operator plus plus is like plus plus x, right? And then there's another one like this, operator plus plus. It takes a dummy int, just a dummy variable. And this is operator plus plus gives you x plus plus. This is our post-incrementer, right? So pre-increment. I should probably above like the other one. Okay, this is our post-increment. Alright. So now, the pre-increment is going to change the value first and then return something. So if I really want to do this, I could say something like node equals node lp next. It would be, think here for a second, if mnode even points to anything valid, then do this. But if it doesn't, I just want to return false, or not return false, just return nothing. Just return. So bail out if that happens. And realistically for this one, I could say it's a const iterator, like k, reference, I could just return this like that. And over here, same thing. Return this. Alright. I can do the same thing over here too. Const iterator k, not t. Oops. This one's a bit harder though, and I can't return a reference because I have to actually like basically create a new iterator that is at the place that we were at before I incremented. Which is why this is stupid. This just shouldn't return anything. But whatever, I'll do it just for the sake of showing it. Const iterator k. I'll say it equals. It's gonna be. How do you do that? I could just initialize it like this and say mnode, and then I can say mnode equals mnode lp next, so it points to the next one, and then I can return it. So return a const iterator that points to the thing that we were already pointing at before, even though our actual class is going to point to something different now. Okay, now we need the same thing basically in reverse. I'm just going to copy and paste these. So I'll make some reverse iterators. Not reverse iterators, but I mean decrementers instead of iterators. So we can move backwards. Okay, this is pre-decrement. This is going to be post-decrement. Yeah, post-decrement. Okay. It's going to be previous. That's also going to be previous. Anything else I'm missing? I can increment forward, I can iterate backwards, I can dereference to get the current node, and I can dereference with the arrow operator to get a pointer to the node, and I can test for equality, I can construct, I can destruct. I think that's everything I need. So now what I want to do, save that first of all, I'm going to copy all this garbage, paste it twice. And the reason for that is I also need a different version of this, which is not going to be a const iterator, it's just going to be an iterator. Const iterator. Replace that with iterator. Yes, 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 yes. Done. Okay. Now, this one has a bit of an issue because it wants to compare both the const iterator and one of its own type. But this right here isn't defined yet. So we need to do what's called a forward declaration. So we're going to say template, type name k, and we're going to say class, const, iterator. Either way, this needs to be forward declared, so this class knows it exists, and it'll like trust me that it'll be resolved at some point when I try to use it right here. Okay, and now we can actually try and use that. Actually, we can't. There's one more thing we need to do. So even though I have these iterators defined, I have to actually be able to create these iterators from the list class itself. So I need methods that return iterators. So const iterator, iterator of type t, because this is coming from the list class, which uses t, whereas the iterator class uses k. So I'm making it with type t, the same class, object type that the list class is using. I'm going to call this cbegin. Okay. Void. It's going to be const. No, except. Yeah. Okay. And do the same thing with cend. Okay. Now I'm going to do regular iterators. And these aren't const. Okay. And they aren't c either. There we go. Yeah. I'm just going to stick these over here. Steal that real quick. Oops. Okay. Alright, now this right here comes from list type T. From list type T. Oh man. Nice and hard to read. So now we have return. We're going to make an iterator that comes from in front. So const iterator type t, but this actually comes from the list class, so it's list t that t. Although I don't need both those t's. I think I could just do this if I really wanted. I'll stick them in there to be explicit though. Why not? Okay, and then these shouldn't both. All right, I did const begin const end, then I did begin end. Yeah, on const for seconds. Okay, like that. Okay, that looks good. And this one won't be a const iterator, it's just regular iterator. Same thing with this one, but it's going to do the back. Okay. Oh, it's disgusting looking. Alright, so I'm going to try and do a new loop here. I'm going to do for. I'll say list, the type was int. Const iterator it, I'll say cit for const iterator, equals list.c begin. C begin. There we go. Cit does not equal list.c end. This is why I have that operator not equals that I made earlier. And cit++ is going to be our post incrementer, which is that operator plus plus int that I made earlier, right? I'll leave that in there even, just so people can review it, right? It's coming from that. This one is coming from operator not equals, right? That's it. This can take either a const iterator k or iterator k, right? Like that. Anyway, now that I have that, I should be able to do this. Standard cout value. I'm going to say cit arrow. Or actually, I can't right now because it doesn't have that. Whatever. I'll get to that in a second. I'll put a structure in there. Let's see if it compiles first, though. Okay, G++, standard equals C++ 20. Just a TP out test. Okay, so what did I mess up? Line 35. Expected semicolon after declaration, I guess. So there's no colon here. Okay, so class const. Same thing over here, I'm sure. Yep. Because I copy pasted it. Cool. Okay, line 160. Const iterator does not name a type. So line 160. Is that right? That's because it comes from list type T. Const iterator. Okay. Funny. And again, I can get rid of one of those t's, I think, so. Because one's dependent on the other, right? So 161, no matching function call to list int, const iterator int, const iterator node int constant. Okay, so 161. Wait, what? Acquired from 291. Oh, because it's also int here, right? Okay. No, still doesn't like it. So list int, const iterator int, const iterator node pointer const. Oh, I know what happened. Okay. So inside of my const iterator, I need to put that class const iterator. What I'm actually passing shouldn't be a reference to a node, it should be a pointer to a node. Okay. That was dumb. Okay, so line 86. Conversion from const node of type int pointer to just regular node event pointer. Line 86. So 86. Where's that required from? So it's 91 and 161. So let's try 161 first. Okay, so this is cbegin, which should give a const iterator. It's list t, const iterator t. Using imfront, which should be type node t, right? Node t pointer, I think. So imfront Yeah, it's a node t pointer. Okay, where is this required from? Line 86. Oh, because it wants a... Okay, I see. Fair enough. So if I do class const iterator. Right, okay. No, it's fine. It's taking a constant node pointer. What's wrong with that? It shouldn't be converting it to node t, should it? Oh, because right here it needs to store it as const. Okay, I'm stupid. Jeez. Let's run it. Okay. Value 0, value 1. But that's from the previous loop, so I don't think our new loop worked out for us. Let's actually do that. Come on. Yeah, nothing's coming out of it. Okay. But it is compiling. We are getting these iterators. So, class const iterator. Let me think about that for a second. So, returning the data from the node. Okay. Equals next, equals next. These are both previous. That looks good to me. This is a regular iterator though. Yeah. Think about that for a second. Those both look right to me. And I'm actually starting M node at whatever the n was that was passed. C begin. I'm doing with M front. C end with M back. Front, back. Okay, where's my loop right here? We're doing C begin and C end. Maybe I'm doing my comparison wrong. Operator not equals. So I'm checking to see that where this reference is. Oh, not equals that. Right? Yeah. No? Okay, but just for fun, standard cout. Operator not equals iterator with const iterator. Which is not going to be called. It's going to be this one. Const iterator with const iterator. Okay. It's not even being called. That's a bit odd, if I do say so myself. Oh, because I'm in iterator right now. Okay. Class const iterator. There we go. I bet this fixes it. Jeez. Value 0. Okay. Interesting. Okay. It is getting called twice. Yeah, okay. As long as it points something valid, we're gonna go to the next. Should do that here as well. If m node can go to the, well, if not that, then just return it. Yeah, okay. Okay, for over here, kind of the same deal. if not m node return it. Okay. That's not going to fix anything, but still good to do that. Okay. If not m node return it. Yeah. Cool. Yep. Now what am I actually putting into the list right now? 0 and 1. Oh, you know what? I see what's happening. So I have list end being the actual address of that node. It's not a sentinel. So I should make it so list end actually returns like null pointer or something. So const iterator. Class that. And yeah. So instead of that, I'm just gonna make it return 0. Or null pointer. I'll be more explicit. Yeah. Return list type T, iterator type T, null pointer. Because it will become null pointer eventually. Yeah, 0 and 1. There it is. And now I could be even more wild, and I could say I have reverse iterator and all that fun stuff. But realistically, if I just make something like, I don't know, CR begin or something, or like I make it like there's a back or something, I don't know. I can make it so that you could just do minus minus. And eventually that's going to bring you to 0 as well. There's no reason to actually define a reverse iterator, technically speaking. But I will make a CR begin, right? So C reverse begin. I'll start it in back. And then I'm going to do, dang it, same thing but non-const, and have a R begin. Yeah. Like that. And that. Okay. Here we are. CR begin. And just R begin. I'll try that next. Yeah, const iterator. I'm going to set equals CR begin. Doesn't equal end. I'm just going to do minus minus this time. I'll do that. I'll even do the pre-incrementer. Or pre-decrementer, I mean. So we should see 0, 1, 1, 0, I think. Oops. Okay, so we have 189 notification matches. 9 was it? Okay. That looks good to me. CR begin. Consular T. It's const no accept. Okay. How about R begin? Const no accept. Okay, that's the issue right there. My non-const version was marked const. Okay, yeah, 0, 1, 1, 0. So see, I made a reverse iterator too, without actually making it have to be something super verbose, where you're like, okay, I need a standard list T, const reverse iterator equals CR begin, you know? Yeah, okay, so then it's IT not equals CR end, IT plus plus, which is weird because you're going forward in reverse. So, whatever. Mine's not completely a clone of standard list at this point, but it has the same function. I just really don't want to add 2 more classes. I'd have to add list T reverse iterator, and I'd have to add list T const reverse iterator, right? That's so dumb. Like, I'd have 4 classes nested inside that other class just to get the functionality. That's just so much repeated code. I'll put that back in just for fun too. I'm gonna make a new type here, and I'm gonna probably end the video after that. So I'm gonna do struct. I'm gonna do I don't know. Let's call it datetime. Let me get lowercase datetime. So everything's public by default. I'm gonna say I have like int year. I'm gonna be real lazy. Int month. Int day. Int hour. Int minute. Int second. Put eyes in front of those. I kind of want to make them smaller types, but for the example I'm giving, I don't really care. So earlier, I kind of explained that I could do something like standard list type, say const iterator it equals some list dot c begin, right? After that, I could do something like it member, right? I could use that because of the arrow operator overload right here. So I want to show that works. So in this case right here, where I'm iterating backwards, I'm gonna make a new list. I'm gonna say, not standard list, just list. I'm gonna call it date time. Okay, list 2. And I'm gonna say list 2 dot push. Let's do front. Okay, and I'm gonna say we have year 2024, month, let's say 9, day 2, hour. Well, it's really early in the morning. 3 a.m. It's 3:48. Don't know the seconds. Okay. Let's do year 2020, and we'll do 1/1. We'll say it's at midnight. Okay. So we'll start at 2020 and get 24 because we're going backwards. Okay, and then we're gonna say we have list. It's gonna be type date time. This is also type date time. But this part here is implied with this, and I might remove those in a second and show that as well. This is list 2 CR begin. This is list 2 CR end. CR rather. Okay. In this case, instead of doing CIT, you know, like this, dot year, right? Year. I'll try that real quick. I'll show you the arrow way too, though. So you can see that works. Oh, 2024 than 2020. Okay. Oh, because I'm pushing it into the start of the list every time. So I'm kind of making list in reverse anyway. So we start out with 2024 as the beginning, and then it becomes 2020 as the beginning and 2024 is after. But then we iterate in reverse, which means 2024 is first, I guess. Oh my god. Is that right? Yeah. That's funny. Anyway, so I can do this instead because of that operator overload that I did. The arrow operator overload. You see, works just the same. So that's pretty neat. It's a lot easier to use. So let's do one thing here. So standard ostream iterator type char. Initialize it with standard cout. That way I can just use format for this. I'm gonna do standard v format 2. I'm gonna do cout. Wait, I didn't name it, did I? I always forget to name this thing. Jeez. I've seen a lot of errors in code where people like do a standard lock guard, and then they'll put their mutex in here, and they'll forget to name it, right? So it constructs it and destructs it immediately. So it locks it and immediately unlocks it before anything else happens in the loop. So the execution is still there. So you actually have to name it LG like this. That's kind of funny. I don't know. I think it's funny. So value. So we have year, month, day. We'll have hour, minute, second, and line break. I don't know the state compile time. Well, actually, I could actually, because it's constant expression, but I don't know where it's going to be in memory and stuff. So whatever. Make format args. Okay. Okay. Yeah. So year, month, day, hour, minute, and second. Okay. Let's give that a try. There we go. Now I should be padding those, of course. So it'd be 2. 0 pad with 2 characters. This would be a 4-character thing. Yeah, that looks good to me. Yeah. So that's how you can do it, man. That's how you can make a list, including how to do the iterators for the list, and the more easy way with the for each loop using a callback function. This is just so much easier. Although, I guess maybe this is a bit slower because it has to call a function every single time. But even this, it has to create a structure and then compare a structure to a node from another structure. Like, if you think about it, every time it's comparing this end right here, it isn't just checking to see if it equals 0, right? It'd be better to have something like is done or something, you know, instead of comparing it to another iterator object, because this end right here is actually constructing a new class object with a node type t that references 0 or null pointer, right? It's constructing it with this. It's creating a list t const iterator t with that as its argument, right? It's making that, and then it's calling on this object that it just made. Let's call this temp. It's calling temp operator not equals, right? Well, I guess it's calling CIT this. It's calling CIT operator not equals on temp. There we go. And that's actually comparing what's in temp, right, by going like this. So it's calling basically temp operator asterisk to get a t and then it's referencing that and comparing that to CIT : m node : let's say t data, right? So it's doing that every single loop iteration. That's really slow. That's dumb. It'd be a lot better just to have something like you know, CIT is done. It would just call a function every time and just it either is done or it isn't. Or I could have some public member or something that of that iterator that just says it's done or not. It could be some public flag. Just a lot of ways you can make things faster. C++ is it's kind of bad in some things it does. If you want to write things completely idiomatically, you're losing a lot of performance. And you might think it doesn't really matter, but if you're iterating over like 1 million or 10 million records or something, it's actually going to add up. I've parsed it before, and this sort of thing does matter. Anyway, if you liked what I've done just now, maybe give it a thumbs up and consider subscribing for more content like this. If you have any suggestions or criticisms, I'd love to hear those. I think in the next video I'm going to make it so that the list is kind of used in a different way. I want to make something like a deck. So maybe look forward to that in the next one. And I will catch you guys later. Have a good day.